Okay, in this video I'm going to show you how you can create randomly generated data sets for your course projects. So I'll walk you first through an experimental layout, and I keep this very fairly small data set, so I want you to see how it all looks and how it works in principle. You can definitely do bigger data sets with more sites or more treatments or more replications. I just want to keep it for the demonstration purposes. I'll keep everything relatively small. So we're creating a data set. I showed you this before in one of the earlier videos, I think, or 3.3. So we'll have a factorial experiments at 2 sites. At both sites I have some sort of treatment. I just call them low, medium, and high, and 5 replications. So we're going to run this. We can look at it. This is our data table structure, and now we can write it out to a CSV file. And let's take a look at this. We can open this in Excel. There it is. So we got 30 observations. So the first thing I'm going to do, because I'm going to modify this with formulas and I want to be able to edit this later. So I'm going to save this as a Excel workbook, and let's do just a few minor things. Fix the ID here. I'm just calling this ID1 and drag this to the bottom. That's better. We don't really need the replication, so this was just part of the grid function. But now we're going to create some variables, and the first one I want to create is height. Let's say tree height, as I'm prone to forestry examples. And I'm going to build my data set by having an experimental mean. So mean height, and then I have a site effect, site height, and treatment height. And you don't have to do it this way, but this makes it easy to modify things later. So I'm going to give the overall mean just a 15. And now we can actually sort this by site. Data sort by site. And I'm going to say my site A, things are growing a bit better. So 3 units better, and at my site B, they're growing 3 units. But this doesn't have to add up to 0. You can put any number there. But this is my side effect, so plus minus 3. And now for my treatments, I'm going to have to sort this table by treatments. So my high treatment, maybe that's a fertilizer treatment or something like that. I want my trees to grow better. Let's say 2 units better. And then for my low, I'd say 3 units worse. And for my intermediate, I say just 1. So we can now create our final height variable here, which is simply this plus that. And there we go. So those are my means for the different treatment combinations, and I can modify this later on. Now, most of your experiments, you will not measure just a single variable, but a bunch of variables. So do create a bunch of variables, and now we actually have the luxury that we can just create another variable just like that. And let's call this one resilience. Resilience. Yes. And yes. And I want this to go the other way. First of all, maybe we pick a different mean just because it's a different measurement on a different scale. So you can put anything there. You can also divide it by 10 or something to make it a real small number. It doesn't really matter. Let's keep the side effect the same. And my treatment effect now, I'm going to do an opposite one. So high treatment, I'm going to make this really small. So I'm going to subtract -1 here. My low treatment, I'm going to make 2. And my intermediate treatment, I'm going to make 0. Okay, and the resilience is already done, so it understood that, and it has now all the correct values here, because that is just a formula that adds all those up. Great, so we're done. We have our data set with 2 variables. You could obviously add more, but let's keep it at 2. Let's save it as an Excel, and then let's save it as a CSV. It's annoying. And let's clean it. Let's clean the CSV up a little bit, because we don't need actually all the intermediate variables here. So this is just this is now without the formula. That's right. So these are now plain numbers that we can import to R. So that's our final version. And we are done here. So we still have the Excel version with all the formulas in case we change our mind later. And we also have our import ready file. So let's read this back in. Take a look at it. There now we have our newly created variables. And now we're going to add some noise. So we just say that variable here in that data table that we just read in, make it the same plus some noise. So our norm 30 is the length of our data table, so we have 30 random numbers, and we multiply it by 3, so this would have a 3 standard deviation variability. So let's do this for our height, for our resilience, and we can look at it now. So it added normally distributed random noise to our variables. That's very nice. And we can control it. So if we don't like it, if that's too much or too little, we can change it. And if we look at a box plot, so let's just attach this and run a box plot. There we go. Let's make this a little bigger. High, low, medium, that makes sense. So our effects seem to have worked out. Now I don't particularly like it if it's ordered alphabetically. So this command orders our treatments in a way that's more logical. It takes this variable, converts it into a factor. So the same variable now gets converted into a factor. It doesn't matter, it probably was a factor to start with. But we want it to be ordered, and then we give the order that we like. So I want it ordered from low, medium to high. So if we run this and attach it and look at it, now my treatments are ordered in a more logical way. So we have side A and side B, low, medium, high. That looks all pretty good. Let's look at the resilience data. That goes the other way around. And it's a bit noisy, but that's the way it goes. That's fine. So we'll just go ahead with this. We can also look at a proper scientific graph for this. So let's run the scikit-plot here for height. That looks very nice. Nice standard deviations. And let's look at the resilience. That goes the opposite way. And maybe the standard deviations could be a little higher here. So let's bump this up a little bit. Let's say 2.5. So let's run the whole section here again down to the line plot, and now it looks like this. So why not? That's good. If you you can actually run this multiple times until you have something that you like. So just go from the read my data all the way to the plots. So you see those change every time a little bit because it is a random sample in a way that we are creating here. So we can do this as often as we like until we have a run that looks good to us, that we want. So if we simulate the data, we might as well take advantage of it. Okay, not much different, but let's stick with this. So let's say we like this one, and we can now also write it out permanently. So I'm going to write it out that to my data one with noise. That way it's reproducible, so you don't work with a new data set every time. Okay, so we could also look at analysis of variance. We haven't done that yet, but you see this all works. We have a significant effect here that we could explore later, and the same for resilience, it works as well. Now, if you find that, this was a bit boring, maybe let's do something more exciting, maybe something with an interaction where, they don't go in the same direction, but one goes up and one goes down. No problem, because you have your data saved as an Excel. And we could now go ahead and say, well, let's do something more exciting for resilience. Let's sort this by site. Maybe at one site, we're going to keep it the way it was. B is a wet site where it doesn't really matter, and A is a dry site where you have some sort of trade-off between some fertilizer and some drought conditions. So the more fertilizer you put in, the worse things actually get in the end if it's dry. Okay, so we already made the change. Everything updates automatically. We hit save. Save as CSV as well. And let's clean it up again. So I want to get rid of these things here. Save again. And let's rerun the whole thing. Let's see what happened to my resilience. So now it goes down at one side and it goes up at another. That may be something that's a little bit more interesting to talk about and to discuss. So you can add complexity, you can change your mind, think about it, and then simulate your data accordingly. So we can also look quickly at an ANOVA here, and now we have a significant interaction here, treatments by site interaction, and we'll obviously cover that later, what that means and how to proceed with this. Okay, so this was my data simulation for an experimental design. All right, let's also do an example for a sampling design, because if you're working in natural resource management or conservation sciences, you don't usually have experiments where you control everything. So let's build on this example so that I don't have to do everything from scratch again. Let's keep one categorical treatment, so site, maybe those are ecological site types. And now I create another variable that's actually a continuous predictor variable. So let's call this one MET for mean annual temperature. That's quite common that you have a mix of class variables that you pick. So you could pick different ecological sites or different regions or different soils that you want to compare. But then there are also other variables that you don't quite have control over. Maybe climate variables that are just varying according to different elevations or something like that. So let's create a random climate variable, and that can actually be done in Excel. So actually Excel also has a random variable function. So this one gives you a value, random value between 0 and 1, but it's not normally distributed, it's uniformly distributed. So it just goes from 0 to 1. Each value has an equal probability. It's good for this purpose, but it's not good for adding noise. So we do that in R. So, but we don't want an MAT between 0 and 1. So I want a range of 10 degrees. So let's multiply this by 10 and let's make a little warmer overall. So let's add 5 and there it is. So those are my temperatures randomly generated. Actually, there's actually lots of data that you don't have to randomly generate. So climate is one of them. I maybe make another video how you can very easily access climate data for any location and any time period. Anyways, let's proceed with this. Let's get rid of the resilience because we already know how to do 2 variables and the video gets kind of long. So what we're going to change here is the effect of MAT. So we're just making this a function of this one here, but maybe we want it a little bit more pronounced, maybe double that range, and because those are quite large values and we don't want our trees to grow too tall, I'm going to subtract -20. So this gives me now different effects, positive and negative, on the height of the tree as well. So let's save this guy and save as CSV as well. And let's read this in. There's our modified variables. We add noise just as we've done it before. So this is normally distributed noise. Attach it and we can plot it. And as you can see, we now have a main effect that's represented by symbols. So our factor site is here used to create different symbols. And then we have just height over MAT, a plot. We see there's a positive relationship. So that's good. Those kind of mixed effects are quite common between categorical and continuous predictor variables, and you can add a bunch more. So it is relatively straightforward. You just add those individual effects to your final height measurements. Good. So this should give you the tools to create relatively complex data sets that you want to talk about in your projects. Don't make it too complicated, but don't make it too simple either. So you want a bit of an analytical challenge, just like you would have in a real project that you design and that you have to analyze.